Hey guys, today we're going to show you the future of antique motorcycle part manufacturing, otherwise known as additive manufacturing and 3D metal printing. I'm Sean from Competition Distributing. Let's get into it. So I'm going to give you guys some examples of some of the things that we're creating now with our new additive manufacturing capabilities. Up until recently, we did everything the old school way, and what we would do is we would make a pattern and make a wax mold off of that pattern of an original part, and then you'd have to take that to a foundry because a lot of times you don't have the heat capabilities that, cast steel versus aluminum and some of the bronze and the lower temperature melting stuff in-house, and you'd have to take it to an actual foundry. And once you take that stuff to a foundry, you have to wait crazy long lead times because a lot of this stuff is extremely low volume. So it doesn't necessarily make it easy for us or the end use customer, because if they want a part or if they want something, we have to kind of plan ahead, way in advance. And then when you actually finally do get the part, it's not finished yet. So when it comes in, we have to finish machine. There's a ton of extra steps to get it to the part just to be able to use it to finish building that final product. So what we here at Competition Distributing decided to do was invest heavily into additive manufacturing. So additive manufacturing has been around forever. The polymers and the plastics and the resins and stuff, that's been going on quite a bit, and it's actually more obtainable now. Everybody that I know, somebody knows somebody that probably has one in their house now. 20 years ago that wasn't the case. So this is a technology that's rapidly advancing, and it's getting more and more capabilities by the minute. So in the metal world, that is also the case, but it's been more behind closed doors until recently. So we're going to be some of the first people to show you the capabilities, our machine, what we can do, and the parts that we can make with metal additive manufacturing. So it's super exciting stuff, and it's been in aerospace, hypercar factories, for end-use parts, automotive world. This is extremely strong stuff. It's end-use parts. Certain processes need to be done after the fact, but it's still way faster if you have your own machine and have the capabilities to do it here in-house like we do now. So I'm going to run you guys through some of this and show you some of the parts that we can actually make and what we're doing with this new technology. And what I read about earlier was the foundry stuff. So this is exactly some of our capabilities now. These are parts that we used to have made at the foundry that now we can do right here in our own shop and with way less time. So this bike here that's in front of me is a replica of an early factory hill climb racer that Harley Davidson used to produce back in the mid to late 20s. And this is particularly like a 26, 27 model. So this bike, I built this bike completely from the traditional methods, being we had patterns, we poured the waxes, we sent those out to the foundry, we waited, got them back, we machined everything, and then I would braze and weld the frame up. So this bike was done, and it took a long time to get to just this step right here, what you're looking at. Now I can do all of this stuff right here in-house, and it's going to greatly speed up our production because these are bikes that we're offering to the public. We have a bunch of these on order right now that we're doing. So these parts here, we actually printed these right here in-house, and we print these out of steel. 316 to be exact, and we post-process, and then you can blast and everything right here in-house. And we have an in-house engineer as well. So what we do is our engineer Kevin, we have a handheld 3D scanner. We scan the parts, the real correct parts, and it brings everything into 0.02 millimeters of accuracy, which is extremely accurate. It picks up imperfections on the surface finish, the parts themselves, all that kind of stuff. And it'll bring it right into the model, and then Kevin converts that point geometry into an actual solid model in our software, and then from there we transfer it into a build pack for our printer, and then we throw it onto our printing machine, and we'll start making the actual part and printing it. And when I say surface correction, this stuff is accurate to every imperfection that's on the original casting or surface finish off of original part. We pick up numbers, We pick up divots, you know, any kind of abnormalities, especially like with casting box imperfections, that kind of stuff. We pick all that stuff up, and it actually translates in from the print onto the part, which is really, really cool, and makes this stuff extremely, extremely accurate to what the original was, you know. And it makes this stuff much more attainable for people and more affordable as well for us to produce. So when we're making frames like this, we're doing every single piece of this in-house now. So this seat post tube for this rebar hill climber, this one we had cast, this one we printed. These axle plates, same thing. We print all this stuff now. You know, this frame in particular has 7 pieces. Our front ends, we produce all this stuff right here in-house. So again, we can do this with any early motorcycle. We particularly focus in 36 and prior, you know, all the way down to like 1908. Harley Davidson's our specialty, but we also can do other brands as well. And we have a full-blown chassis fabrication shop, as well as we make tons and tons of engine components, and we're actually using, you know, additive manufacturing to do that as well. So let's take a walk. I'll show you guys some of our capabilities. On this bench here, you can see this is a bunch of castings that we've recently just printed here. And what we do, and another reason that makes this so much more beneficial for us, especially as a small company, is this process completely eliminates the post-processing machining for these particular parts. Not in every aspect of what we do, but for frame castings in particular. Kevin can go in on our models and he can adjust the size of like the tubes and the slip joints for the tubes that go into our frames, and we can print this to tolerance. So because our printer is accurate within a thousandth of an inch. So what I mean by that is, before, when you would make a casting of this exact piece, you would come in after you get that casting. This would be a solid chunk of steel, you know, doing it the wax and slurry method, unless you invested heavily into an individual pattern, which would be an investment casting at that point. And then you're going to have $20,000 to $30,000 of machining into just one pattern for one part, which again, if you're doing low volume, it makes 0 sense for, you know, especially really old parts like this that you're not really necessarily going to sell a ton of. So this makes it way more obtainable for everybody. And when I say that is we can print this right to tolerance, and there's no post-processing machining. So this is awesome for speed. You know, if somebody needs a part, or if they want an individual casting for something, they can reach out to us and be like, hey, can you guys make this for us? If we already have it made, if it's already in our database, we can go, yeah, we can make that. And depending on what we have on the printer right now, we can load this onto a build pack, and we can print this, even if it's not with the same parts that are already on there, we can squeeze it in somewhere on our build plate and print one of these. So it makes it really, really nice for especially these really old parts. And post-process machining eliminates all that, which is great. So we can print threads in really close tolerances. The threads you can print, you can come in and just chase it with a tap after you're done, which is really nice. Or you can just print to, you know, tap drill size, so you can come in, drill it, tap it like the traditional method. Either or, it doesn't matter. But like I said, we can print threads with the steel as well. This is some of our future production stuff that we're working on right now here at Competition, and this is again a thing that's making all this very viable and very easy for us to make it more affordable and more available to the end customer. And when I say that, our cylinder line, so these are completely made by us here in the States, and we print these cylinders, and we do it out of a couple different materials. We have the ability to print out of titanium, aluminum, as well as stainless and other materials as well, but those are our primary ones that we use here. These here are an aluminum version of our cylinders. We print these with some extra stock, and then you come in with a 5-axis CNC, and we machine everything. And our aluminum cylinders will be Nicosil coated on the bores. And then, you know, when you get them as a customer, they'll be ready to put on your bike and run for early JDs. So we can do every early model, late model, all this stuff. And before, you would have to make patterns for every one of those, spend a bunch of time in developing those patterns, and wait on the foundry, then, you know, post-process machine, just like anything. But this makes this much more attainable. So now we don't have to have all that. We can keep this stuff on the shelf, keep it in stock for, you know, make it accessible to people. So very, very cool stuff. These are aluminums, these are our steel versions. We're doing complete engine cases as well. We have a JDH line coming out, a 2-cam line for you know, more race applications, that hill climber I showed you earlier, as well as some board track bikes and that kind of stuff. So all this stuff we can do in-house. This is our rods that we make, connecting rods. We printed these, and you can see our name in there. You can customize them, and that's the other great thing about this. If a customer has a specific spec they need to make, or a tolerance or anything like that, we can make adjustments and do that. So if you're running like a stroker motor, or if you're, you know, de-stroking something, whatever, we can change that rod length and keep all your critical dimensions on your bottom end, so you don't really have to change anything else like flywheels or anything like that. So very, very cool technology, and it's kind of revolutionizing the way that we're able to do stuff now. So last year for the Born Free competition, we decided to build our own version of an 8-valve, overhead 8-valve racer, board track racer for the Born Free show. And we developed pretty much that entire top end for that engine, and we based it off of an old late 20s Rudge, which was a British racing bike, a single cylinder, and they were made out of cast iron, the heads. And we took that Rudge design of the cast iron, and we kind of made some improvements to it as far as porting and port geometry and that kind of things. We increased the intake port size as well as the exhaust port, and made the transition and flow better. So after doing that, obviously we printed those heads in aluminum instead of cast iron, you know, making weight and heat dissipation way better. So, and then we made cylinders for that bike, had a stock JD 25 bottom end, and made a race engine out of it. And we did it all with using additive manufacturing. So, like, again, this is stuff that would require a ton of time and investment in patterns and molds and foundry time that now is completely eliminated, and we can do it all right here in our facility. And when we printed all this stuff, we print it undersized ever so slightly, so that you can come in and just dust for your final tolerance on your valve seats, your guides, all that kind of stuff for your press fit, or however you want to get that to meet that critical dimension. So very handy if you're doing any kind of engine design or engine components or anything like that. This stuff is extremely strong. Again, they use it in aerospace every day for end use parts and automotive, and as well as hypercar and supercars. All right, guys, so this is our additive lab. This is where our purging gas and stuff is to keep the oxygen out of the chamber in the machine, and it purifies it while it's actually doing the process. And this is our powder conveyor. This is what transfers all of our powder into our machine. And then we have our powder sieve over here. And what that does is it actually cleans the powder that doesn't get used in the initial print, and you can recycle it back into the hopper itself. So right now we have a build going on. It's a complete frame pack, so it's actually some of the castings I showed you out here earlier. It's for early JD frames, J model frames, particularly 20s through mid 20s and early teen or late teens, I should say. But again, we're printing in a complete frame pack in one go. So what I mean by that is every single piece to construct a frame for a JD is on this one print. So this particular build is about 55 hours. So we'll kick this off, and this thing will just run continuously layer by layer and print all these parts for us. And you can see the recoder going back and forth here. This is the camera, and it does this in layer by layer form. So we're doing these out of 316, and it's a powder form, and the powder has the consistency of like flour is the best way to describe it. It's very, very fine. You don't want to breathe it in. When we're in here, open powder situations, we always wear respirators just to be safe so you're not inhaling that kind of stuff. But it comes by, it goes up through the machine here into your hopper. It comes down into your recoder. Your recoder slides across the build plate, and when it comes across, it lays a fresh layer of powder every time. And then the lasers come in, which you can see here right now. It's lasering the part. It's laser sintering those layers in the fashion that we oriented them onto the plate. So this particular build, we have this set up for 60 micron layers. So the thickness of every one of these layers it's sintering is in 60 microns. And it'll do this all the way through the part until it gets to the very top, and then the build's done. And a lot of people ask me, well, is this as strong as a casting was? These prints are actually stronger than a typical casting will be, 2 to 3 times to be exact. There's been tons of degradation testing on this stuff, We've done automotive standard testing on this stuff, and these parts are stronger than a typical casting. So there's no voids, there's no imperfections anywhere through. Whereas a casting, you could have, you know, an air pocket or imperfection or somewhere that the molten metal didn't get into on your mold or your pattern, whatever you're doing. And when you're doing it like this, layer by layer in 60 micron, this part comes out 99.8% dense. So your density is far greater, and at the end use, you have a really, really strong part. So some parts, depending on the material, you can do post-process heat treating with. These we don't really have to stress relieve off the build plate. Our 3/16 parts that we're making, we don't really stress relieve too often unless it's like a cylinder or something like that. But these come off the plate after we let them cool down in the build. We use a really high-end support material system. It's a lattice, and we can just kind of snap it off the plate. And you take a grinder, clean up the little spots where your heat sinks were on, and then we run it through our blaster, and you'll have a nice clean, ready to go in-use part. We're gonna start a new segment here in the future. Once a month we're gonna start out with, and we're gonna ask you guys, the viewer, to send us an STL or step file of a part that you wanna see printed on our machine. And it's gonna be called Will It Print? So what that entails is anything that you guys can design or come up with that you wanna try to print out of metal, you send us that file, that STL, that step file. We'll in turn put that on a build plate and throw it in our machine. We'll show you guys the process. You know, we'll throw it on here and walk you through the step-by-step of what that takes to actually get the end part out. And whether it prints successfully the first time or not, you guys will get that part. So it's gonna be kind of fun and interesting to see what you guys can come up with, throw at us. You know, the more intricate, the better. Kind of a fun little thing we're gonna do. We're gonna see if you guys are interested. It kind of makes it so you guys are involved in what we're doing, and it also gives you kind of an outlet to see what your design is like in metal. So pretty cool stuff. Make sure you stay tuned. Hey guys, thanks for watching. You know, we're just scratching the surface on some of the stuff that we're gonna be doing here, and it's a really exciting time for us. So if you guys are as excited as we are about it, make sure you hit that like and subscribe button. We're gonna have a ton of new stuff coming at you this year for 2025. We're really focusing on all of our new capabilities and things that we can do here on the vintage motorcycle world. So if that's something you guys like, you know, make sure to follow along.